Hello everybody. Today I'm here with my teammates to talk about on the topic leakage reduction by gate replacement in PMOS VLSI design. So talking about leakage, what is leakage? A leakage current that may be responsible for static power dissipation during idle mode are increasing dynamically in sub 100 nanometer processes. Sub-threshold leakage rises due to the threshold voltage scaling, while gate leakage current increases due to scaling of oxide thickness. So the transistor we are going to use topic is PMOS transistors. So PMOS transistors operate by creating an inversion layer in an N-type transistor body. The inversion layer called the P channel can conduct holes between P-type source and drain terminals. The P channel is created by applying a negative voltage up to minus 25 volts to the third terminal that is called the gate. So moving on, Pritesh will carry on.
So thank you, Nachiket. As my friend Nachiket has explained the basic two terms, what is how does a PMOS transistor works and what do you exactly mean by gate leakage current? I'd like to further add on the techniques which we'll be using for the leakage reduction by gate in this current implementation. So basically, as we can see, we'll be using conventional gate replacement techniques and like as we can see in the second point, and further we would be using in the standby mode in the circuit the traditional GR approach is used, which will be gone. Also, an important point which we can see is the IVC approach, which does now no longer minimize the leakage, while the common sense intensity of the circuit is better because it considers the complete circuit, the whole circuit, as a block. So the pseudo code for the WS free node algorithm for GR, like as we can see in the given slide, what at what stage the GR happens and what does the GR do? It basically checks and replaces the WS for each gate at every stage till the ultimate stage is reached, and we can see what our input is and what do we need to be what does our input need to be. It is a levelized net list standard cell library, and our output basically what is a primary concern going into this implementation. What do we actually want at the final stage? A circuit basically which minimizes leakage without changing the behavior in the active mode. So here it is given. This is the basic code which will be required and which will be using for the implementation and the explanation. It's a very simple code as we can see in the slide, and the explanation of every line is given side by side to it. So now basically the what do you mean by PMOS stacking? As my friend has explained, there were two terms as we said. The first was the gate leakage explanation and how does a PMOS transistor work. So now if the concept of how does a PMOS transistor work is clear, we can talk more about this. C17 circuit is a circuit which we'll be using for our implementation. It has like five number one inputs and number one outputs. According to the proposed algorithm, the algorithm which we'll be using in our implementation, first each enter is ready at a low level, that is zero voltage, the given initial level which will be zero voltage, and the proper flow and the implementation will be given in the next slide in the circuit diagram. So, but I'll just read it out for you as proven in table 1. The leakage of every gate is dependent at the enter vector as displayed in figure 6a, which is again in the next slide. G5 and G6 are of their WS in line with the WS loose node algorithm, and those gates are changed with the aid of using an appropriate variant. Hence, the full leakage width inside the preceding case becomes 5395 Na, wherein a 42.4 Na leakage passed out beneath the WS circumstance. So here, as we can see, it's the first diagram is of a leakage current of C17 circuit by conventional circuit, and the second is modified C7 circuit by applying proposed technique, which we discussed earlier. In conclusion, I'd like to say that scaling down the circuits of complementary steel oxides having will increase the leakage modern day. Input vector manipulate is an exceedingly famous technique for controlling leakage without the usage of any technological modification. How it's miles much less powerful for large common sense intensity circuit. Our examine proposes a worst leakage gate WS. This is exactly what WS means. Free node set of rules primarily based totally on a gate substitute technique. in which while the common sense gate of a given circuit is going into the WS, its miles changed with the aid of using an appropriate version of the gate which in flip reduces the leakage modern day and add-on mode of the circuit of the identical enter vector. So yes, like these are the references which we used in the current slide, and I'd like to say thank you so much for hearing us out.